Hi friends, I hope you're doing well. Today I came across with another set of interview question which were asked in Tata AIG Insurance Company. So in this section I'm going to share the 10 question which out of 30 question 10 question I'm going to share here, and it is totally focused on the Spark, and total interview duration was 1 hour. So I will cover one by one, and I am going to give answer as well. So if you have any suggestion, you can write out into the comment box. I will try to improve my explaining and interview experience. So I'm starting the question. So first question they asked me, tell me about yourself. Tell me about yourself. So simply I told I'm Abhishek Tripathi. I have done graduation from Birla Institute of Technology and Science. Currently, I'm working with a Cognizant as a data engineer. I have a experience in SQL, Python, PySpark, ADF, and then they asked me background of your project. So whatever you have done in your projects, you have to give the background in your projects. And then another question they have asked, what exactly your pipeline doing? So suppose you are creating any pipeline, so what are you doing in pipeline? What are you doing? What is the source? What is the target? Who is the end user? What are the intermediate transformation? All the things, how you divided the layer, all the things you have to explain in front of him. Another question they have, I'm going to start from here. Another question they have asked, what kind of transformation you have implemented using PySpark, data bricks, and ADF. So I told him some simple. First, I told him PySpark transformation. So I told him I have done the transformation like schema management, data cleaning, data aggregation, join app operations, custom transformation, and time based operations on there. So I will explain what is the schema management, what I have. Then he asked one by one all the things, and I have explained on there. So I have written here and will let you know. So schema management is nothing but, suppose I'm getting a file, flattening nested JSON structure into the flat tables, handling schema evaluation, especially with the nested and complex feed, defining custom schema to handle diverse data types like structure and array type and map type. So I will give the live example. Suppose I am the business has given the one file, that is a CSPR, JSON or text files, and they told me that the schema is never going to change. We asked ki whether whatever schema you have given, that will change in future or not. So they told me that it will not going to change in future. So for validation purpose, while I'm writing the I'm going to read, and I'm going to read, after that I will validate. I have to write one function that will validate the schema of the everyday received files. If it is correct, then we will proceed, otherwise it will not going to proceed further. So this is the way I have implemented in my project. So last project. So right now another part, data cleaning. So data cleaning is a very important part. Suppose I'm getting the null records in the particular files. If it is unknown null, known null is okay. If it is no unknown, so we have to manage the null. Duplicates, sometimes they told me that they told us ki we are not going to provide a duplicate records, but we have to apply the checks on there. Suppose by mistake, that is the manual file they are going to provide, it contain the duplicates. So we have to check the duplicates as well as and outliers also, and converting data type and handling the type mismatch, like string to timestamp or array to struct as per requirement. Sometimes whatever file we are getting in the file, there are date columns, so that is different format. So we have to, as per business requirement, we have to convert that date format as per requirement. So we have to change to string to timestamp on there. Then another part will came data aggregation. So data aggregation is nothing but grouping and aggregating data based on the multiple fields, based on the multiple fields. So like computing multiple fields, like computing and another point is computing rolling average and cumulative sum. like the such type of any option, any question requirement came, so you have to do like do on the based on the like aggregation on there. Another part will came join operation. So in transformation join operation, so you know that your project, every project has a different data frame and different data collection, master data. So we have to join and create a one particular data frame, through that we are going to provide to the consumer, who is the downstream person, who is the visualization purpose. So we are you going to use the join also on there. Another part is that custom transformation. Custom transformation is nothing but a UDF, user defined function, and that custom logic. Whatever I required, I have to write the function and will implement in the particular while reading the data frame. While doing the after reading the data frame, I will apply this user defined function on there. And implementing conditional transformation, like replace value based on the condition. So based on the condition, we want to replace the something, so we have to write the conditional transformation on also on there. Another part is can come is with time based operation. So time based operation is nothing but converting time format like string to timestamp, extracting part of the timestamp. Suppose I want to give the year part only, so I will apply the year transformation. Suppose I want to month only, so I have to give the month only. Suppose I want to day, so I have to give the day on there. And calculating time difference or duration, and calculating time difference or duration also if required in our project on there. So after that, I told you this is the PySpark transformation which I have used in PySpark. Now they asked me for ADF transformation. What are transformation you have used in ADF transformation? Then I told first data movement. So suppose I my data is located on the located into the on-premise system. So I have to read the data and store into blob storage or any other storage, any file format, any other format, any other place I have to store. Then we'll read from there and they'll load into the Azure Delta Lake. So this is the one transformation. Then another, managing incremental data load like delta load. So suppose I want to read incremental data, means supposed to based on the date column, based on any certain column, key column. So I will apply this transformation, managing incremental data load transformation. Another, they will ask mapping data flow. So apply transformation like filtering, aggregation and joins. Mapping data flow, suppose I want to pull only that record that sets belong to the USA. And aggregation is nothing but I will perform the sum of aggregation, which means some of the five. I will give the example of aggregation later. And join, we will make a join with master table. If it is available in master table, then it will pull, otherwise it will not come. So I will use a mapping data flow on there. And handling conditional split for routing data on there. And another part is format conversion. So suppose converting between format like CSV to JSON, or JSON to CSV, or JSON to Avro, or a packet to or delta. So as per your convenience, you have to use this these file formats on there. Another part, we have to give the parameterization. So you've seen that while you're creating pipeline, or if you are new, so you have in your organization there are too many pipelines are created. And that pipelines, you can see that there are too many parameterization parameterization created on there. So like creating parameterized pipeline for dynamic data ingestion and processing for dynamic data, not statics. There is no fix. Suppose there are as they told me that we in the on-premise database there are 10 table on there, 10 table on there. But sometime it will increase and decrease, it will increase the table also and decrease also, sometime it will happen. So in on that time you cannot rely on the static transformation. You have to write the dynamic parameterized for technique to process the data. After that, another part will come data validation. So data validation, how you can do the data validation on there. So data validation is nothing but using filter and derived column from the validation. So whatever columns are there in a source, and you have to match with the target, whether it is correct or not, or count is matching, all the things, whatever way you perform, way you want to do data validation, you can do on there. Now I'm going to come with a database transformation. So database transformation is nothing but delta lake operations. First delta lake operations. So like we are going to perform the merge data into the delta lake table, merge into statement, or performing upsert, or handling schema evaluation in the delta lake delta tables on there. Then we have to write, we have to use SQL and PySpark integration in notebooks, whatever is there. So write SQL query directly in the notebook for transformation, or combining SQL and PySpark for more complex operation on there. And there is a data pipeline. Suppose you want to extract, you want to schedule a job, so there is a job schedule option in Databricks. You can use build ETL pipeline using Databricks job, or using workflow to manage dependency between different tasks on there. And another part will come performing optimization. So Databricks comes with a different optimization technique on there, just like partitioning and bucketing large data set, optimizing joins and shuffles on there, using jet ordering or liquid clustering. So these are the things on there in performance optimization and database part on there. So this is the first question they have asked, he asked, and I have given the answer. Now I'm going for the second question. So second question is nothing but, have you done any aggregation? Can you tell me how you have implemented in your project with the example? Then I told him simply, yes, aggregation are I have done, and aggregations are fundamental part of the data processing in the PySpark and other ETL workflow. So below I will explain how I have given the example here, how I have implemented aggregation in project with the practical example. So suppose I have a data, imagine I have a data set that contain daily sales record with the following schema, like date, product, region, sales, and quantity. Suppose first of the number, there is a product A in region east, sales 500, quantity 5. And same day product B west zone, 700 sales and 7 quantity on there. You can see for second of the number. And then my objective is that calculate total sales and quantity sold per product, or find the highest sales region for the each product. Then what I will do, I will create a PySpark code and through data frame, and through the data frame I will perform the above questions answer. So I have imported the module whatever required, like PySpark or SQL, that frameworks whatever required. Import Spark session from PySpark.sql.functions, import column sum max first. Then I have created one list that contain the data, and I have created the column that contain the schema, means column columns name, and this is the insert row whatever under the columns. And then I have created the data frame, and in this data frame you can see that the all the columns are created: date, product, region, sales, quantity on there. So first I will going to come first I am going to calculate total sales and quantity per product on there. So first I have given data frame based, I will do the group by based on the product, and I have done the aggregation sum of the sales, whatever sum of the sales, I like a total sales, and sum of the quantity like a total quantity. So here if I'm going to so you can see the product A, product by A, I'm not considering any date. Product in a week or in a month, to product A total sales 1100, and quantity total sales 11. And for product B, the total sales happen 1500 and total quantity happen 15 only. So this way I have done. Another question is there: highest sale region per product, highest sales region per product, per region highest sale. they want. So I will group the data based on the product and region. Based on the product and region. Earlier you see that I have done the group the data based on the product. Now I'm grouping data based on the product and region. Then I'm aggregation, doing aggregation, sum of sales, alias region and region sales, and then order by product and column I have given the region sales as a DESC. One I have given the ASC, and another I have given the descending order, ascending order and descending order. Then I'm going to show the things. You can see that product A and product B, region by east region have performed the 1100 cent, west region perform 1500 cent on the year. Now another part is the find the top region for the each product. Find the top region for the each product. Then I will go, then what I have done, I will do, I will do a group by based on product. Then I will use another function like the ready-made function. This first, then region that alias is top region, then first, then region sales. I am performing this activity on data frame 2. I am performing this activity on data frame 2, not data frame 1, whatever main data frame I have created. Then you can see the region sales, that's top region sales. Now if I'm going to show that, so it will give the product, this one top region east, and top region sales 1100. If you have a more data in your table or data frames, you will get the better output on there. So this is the way I have performed the this is the way I have performed the activity here. Okay, highest cell top, find the top region here. So another part is that how this was used in project. So how this was used in project, I have given the example, but I want to how this was used in project. So in a real project, aggregating KPIs for a retail clients, suppose I have a retail client working for retail clients, I calculate KPIs like total revenue, units sold, and average revenue per unit across different product and region. Suppose I am working with a Tata Motor, and Tata Motor have a different product. So I want to calculate the total revenue, total units sold, and suppose I want to work for the Nexus EV section. So how many total revenues generated for that, how many units sold, and average revenue per unit car across different product and region. So I have to perform this activity on there if I'm working with that. Like performance dashboard, the result of the aggregation, whatever you have created result, and you are going to store any table, any location in file format, you are going to share in different person. So that result of the aggregation were fed into the dashboard for business stakeholder to monitor sales performance. So whatever, once you have created table, then you have shared to the BI person. The BI means visualization person who is working with that. Then they will create a dashboard on top of that, and they will release the report. And after releasing report, it will show to the stakeholder who is the means VP and purchase and all the thing peoples on their particular area. They will do their assumption, and they will perform, they are going to work on top of that if any positive or feedback on there. So after that, optimization query for larger data. So suppose I have working with a larger data set, I partition data by region or product and used caching to speed up the repeated aggregation. So whatever aggregation coming again and again, so we will do the caching and speed up the repeated aggregation. So this is the aggregation how I have done here. Now I'm going to the optimization part. Means in term of optimization, what are technique I have used in my project here. So I will let you know. First I have used partition and bucketing. So why I am using partition and bucketing? Reduce the amount of data shuffled during operation like join, aggregation, and filter. Join, aggregation, and filter. Why means reduce the amount of data shuffled during operation like joins, aggregation, and filter. Now they are going to ask how you are going to implement. So partition data based on the column with a high cardinality such as a reason or date. So if you are going to do partition and bucketing, so there should be one known column, you know that is not going to change. not going to change. Like a date column, for any record created, that should be unique, it not going to change. Many update and other things will come, but in created it will not going to change. And bucket for partition purpose, and bucket data for the operations involve frequent join or grouping on there. So this is the partition and bucketing on there. And how can I implement here? Df dot write dot partition by based on the region, then dot write parquet, and I have to give the path where I have to write. Same way I will do, instead of partition by, I have to use the bucket. How many buckets I want to create? For 10 product, then sort by product, save as a bucket this way. So I will explain the bucket by how it is going to work in upcoming session. So it would help you a lot, because if I'm going to explain and this one also, the session become huge, timing become huge, so I want to keep a short. And so another part is caching and persistence. So caching, why we are using caching? So you use the same data frame multiple times without recalculating it. So you know that Spark is lazy evaluation. Once you will do action, then it will again and again recalculate. So what we can do here using cache and persist, we can store in a certain period of memory, portion of the memory, once calculation done, and we use it again and again with our calculation purpose. So how I can use dot cache or dot persist to store intermediate result in the memory or disk. So you know that caches support only memory storage location, and persist support memory and as well as disk also. So if I want to perform the I want to perform the df.cache. So here you can see that cache data frame to reuse the in multiple transformation, like df.cache I have done. Then again I am doing the group by and showing again. And when to use persist, when to persist dot persist, we don't know the memory size of our cluster and other things. Then that time we can use a persist with the storage level, memory and disk for large data set that might not fit in the memory. So because if I don't know the configuration of the memory, if I'm storing the large amount of data, suppose I have memory configuration is 30 GB and I'm storing 40 GB data, so it will provide a out of memory OOM issue here. So wisely use persistent cache on there. Now I'm going to another part is that avoid white transformation. So when you are working with a data frame in PySpark on there, so it is recommended that white transformation, why we are not going to use white transformation? So white transformation like group by join and repartition requires shuffling data across node, which is expensive, sorry. So so that's why how expensive. So that's why we have to avoid this on there. How minimize the white transformation, not to use on there? So use narrow transformation like map, filter, select where it's possible on there, and combine multiple operation to reduce intermediate stage on there. You know that if I am applying the white transformation, another stage will be created, another stage will be created on there. So another part is come use broadcast join, use broadcast join. So broadcast join, what is performance technique is broadcast joins. So why we are using? So preventing shuffling for a small data set during the joins. How it will prevent? So broadcast smaller data sets to all the worker node, all the worker all the worker nodes. So how you can perform the broadcast? So simply this is the syntax here. Result large data frame df dot join broadcast small data frame dot key. So I will explain in brief, not explain explain in the upcoming next set of video with the broadcast when he interviewer ask 4 to 5 question on broadcast. So I will explain in detail in next video in broadcast part, because it is, if I'm going to explain, it will be video will create for 1 hour and more than 1 hour, so it is not going to good. So and I'm going for optimized file format. So optimized file format means we have to choose that file format. So that have, why efficient storage format that reduce input output overhead. How? Use Parquet ORC instead of CSV for large dataset due to their columnar storage format. So columnar storage format. So I will explain this one also. What is the columnar and what is the columnar and how it is work. All the things I will explain in upcoming video on there. So how will then I will write into how I can use the syntax. So syntax is nothing but df.write.mode override. I have to reuse the Parquet data frame. If I'm not using Parquet, I will use ORC or CSP or JSON. Any file format I can use give here, and then I have to write the path. So there are different way we can use the how read and write method in PySpark. Now I'm going for the optimize shuffle partition. Optimize shuffle partition. What is this? Why? Q. Reduce the number of shuffle partition to balance between performance and memory usage. How we can reduce? Set an appropriate number of partition based on the data size. You know the data size, how many, how, what is the volume of data set, and you can perform this way. So I have to give the configuration like spark.config.set spark.sql.shuffle.partition 200. So by default 200 is coming. Default is often 200. Tune based on the cluster size. If you want to less, if you want to increase, you have to decide your according your data. So how much of data is coming. Now it is coming for the filter push down. What is the filter push down? Filter push down is nothing. Why is nothing. Filter push down is what is the, so reduce the amount of data read from the source by applying filter early. And how? Use data source capabilities like predicates in JDBC, Parquet, and Delta. Suppose I am reading from the JDBC, so I'm reading for reading from JDBC, and that table contains the 600 column and 10 lakhs record, 1 CR record on the rows on there. So I do not want 600 column. For my requirement I need only 4 to 5 columns. So I will select only 4 to 5 columns, select from the particular table. I need only for that file contain the whole India data, but I need only for Karnataka data. So I will go for the only apply the filter state equal to Karnataka. Any other I want to filter based on the I want to filter any other filter condition you want, you can apply on there. But you can filter push down based during the read time also. So that will reduce the it will create a list data frame with the less data, not for huge data set. Okay, this is the filter push down. How can we do go for that? Now another part is the use data frame over RDD. Why? Well, why we use the data frame over RDD? Because data frame are comes with the optimized technique by default by Catalyst optimizer or tungsten execution engine means optimizer, unlike RDD don't have. So how we can implement? Always prefer data frame and Spark SQL APIs unless RDD are absolutely unnecessary. Okay, so another part is another optimization technique is use delta lake for incremental load. So why? Delta lake provide ACID transaction like schema evaluation and optimize read on there. That's why we are going for the incremental load work with the delta lake, and use delta for upsert to merge and time travel queries on there. Now another part is the columnar operations. So PySpark is optimized for the columnar operations. Like you know that columnar. So I will give the example. Columnar operation. What is that? Avoid row-wise operation. Use function from function dot SQL dot PySpark SQL dot function. So you know that there is the one technique like select df dot select there already automated function is given there like like I want to select only specific column call. I will give the here name like that. So this is the related to this column. This type of function you have to ready-made function you have to use. Do not go for the UDF user defined function because that is a costly as compared to these functions on there. So now another part is monitor and tune. So suppose you have created the your data application and your the job is running it well. So you have to monitor through the Spark UI and stage and task and execution plan, and you have to you have to perform if anything, identify the bottlenecks, improve overall performance. You have to perform where it is taking time and why it is taking time, what is the reason behind that, and try to fix the things. Then it will improve the performance of your job. So today it is sufficient, and whatever recorded video I have, I think in near about 30 minutes. So I do not want to go more than 30 minutes. So I hope you enjoy whatever I have explained here. If any suggestion, any for improvement, explaining purpose and questions related things, you can write in comment box. I will try to improve. Thank you very much for watching. Keep like, keep subscribe my